A very good morning to all of you. Myself, Dr. Varun Narayan Mishra. Today, we are going to discuss about the role of different remote sensing satellites in land information system. Today, we will discuss the properties and characteristics of different satellites, different sensors which is available, and what are the properties and how we can use these remote sensing satellites in development of land information system. As we know that the remote sensing satellites, or you can say the earth observation technologies, are very much important for land information system. So today we will discuss some of the broadly used satellites, some of the broadly used satellite images around the world in the development of land information system. Okay, so these are some major satellites which are now available in the remote sensing community. That is Spot, Landsat Series satellites, Iconos, QuickBird, and Worldview. These are one of the widely used and major data sets available satellites. When we talk about the Landsat Series satellites are widely used for different applications. Iconos, QuickBird, and Worldview. These are the high resolution satellite images, and they are very much useful for the detailed urban mapping, detailed urban planning, or the development of very effective land information system. So before start, I would like to start with the Spot satellite. So the Spot satellite is launched by the France. Okay, it's operated by the French space agency that is known as Centre National d'Etudes Spatiales (CNES), and the full form of Spot satellite is Satellite pour l'Observation de la Terre. Okay, so this is a French satellite and launched by the French space agency CNES, and the series of Spot satellites have been launched, means with the starting of first satellite of Spot series that is Spot 1, which was launched in 1986, and then second satellite of Spot series Spot 2 was launched in 1990, third satellite was launched in 1993, fourth satellite was launched in 1998, and fifth satellite, that is Spot 5, which was launched in April 2002. So there are a series of satellites of Spot space program or Spot satellites. So Spot satellites are the satellites which is based on the sun-synchronous orbits. The satellite passes over the same part of the Earth at roughly the same local time each day. As we know that most of the remote sensing satellites are sun-synchronous, so Spot is also a synchronous satellite, and it can pass over the same area on the Earth's surface at the same local time every day. And its inclination angle is around 8 degrees of the polar orbit. And the fact that the Earth is not perfect sphere makes the orbital plane rotate slowly around the Earth. So this would not happen if it were perfectly polar. These are some of the facts about the Spot satellite. The slow motion of that orbital plane matches the latitudinal motion of the sun in the sky over the year. It maintains the similar sun angle along its ground trace for all the orbits. That means that the area the sun flies over always get the same sunlight angle, which gives the constant lightning. Moving to the next slide. So each Spot satellite carries two different types of sensors. It is having two sensors. One of the sensor is known as HRV. Its full form is high resolution visible. Okay, it's a multilinear array detector. It's a kind of push broom scanner, and these push broom scanners are also known as along track scanners. So the HRV sensor, that is high resolution visible sensor, is a push broom sensor. It works in a long track motion, and they record the multispectral images along a wide swath. Multispectral images means it receives the energy, or it records the electromagnetic radiation in different spectral bands or different wavelength intervals. So it can be considered as the multispectral images. Okay, so in case of push broom sensors, when we talk about along track sensors, so these kind of sensors generally uses a linear array of the detectors. Each detector is sensitive to a specific wavelength interval. Okay, so it senses a single column at a time and uses the forward motion to generate second dimension. And in case of spot satellite, the ground sample distance, which is also known as GSD, it's a resolution by sampling interval and normally results in just touching square pixels making up the image. Each spectral band of sensing requires its own array, and in case of push broom scanners or long track scanners, it is having generally the higher radiometric resolution. Okay, these high radiometric resolution is because of longer dwell time and in respect to the across track scanners. In case of across track scanners, it moves laterally across the landscape as also move forward. So when we compare the push broom scanners and whisk broom scanners, or we can say the along track scanners and across track scanners, in case of along track scanners, we generally have improved radiometric resolution in comparison to the across track scanners because of the longer dwell time. Okay, so also the spot satellite, or you can say the sensors mounted on the spot satellite, works in two different modes. It works in panchromatic mode as well as multispectral mode. In case of panchromatic mode, it receives or it captures the images in a single spectral band that is corresponding to the visible part of the electromagnetic spectrum, and its range is from 0.51 to 0.73 micrometer. And this single spectral imaging mode yields black and white images. Because of this single spectral band, panchromatic sensors provides the black and white images, or you can say the gray level images, and the resolution is 10 meter for panchromatic mode, and pixels per line is 6000, and it's very good for fine geometrical details. And second mode of the image acquisition for spot satellite is multispectral. In multispectral mode, it captures the images, or it captures the electromagnetic radiation in three different spectral bands, that is covering from 0.5 to 0.59, that is green band, then 0.61 to 0.68, that is red band, and third one is 0.79 to 0.89 micrometers, that is the near infrared band. And in case of multispectral mode, the spatial resolution of the images will be 20 meter, and the number of pixels per line is considered as 3000. So two different modes, or you can say the spot sensors works in two different mode with different spatial resolution and different number of bands, and both are having different applications as per the requirement. When we are going for high resolution images, so we need to go for chromatic mode images, and if we want to have the medium resolution images, so it is better to use multispectral mode of the spot satellite. So these are some of the sample images acquired by the spot satellite. This is the image showing the false blood composite over the Australian region. Okay, so this is the website where we can purchase the spot images by prior order to the required image of any area. Okay, these images are not freely available, so you need to order before purchase it, and they will provide you the uh, images as per your requirement. Second very famous satellite is Landsat. Landsat having a series of satellites. It is one of the most widely used remote sensing satellite for different applications. The first satellite of Landsat series was launched in 1972 by NASA. Okay, and since 1984, the satellite operation and land handling are managed by a commercial company known as EOSat. So initially, its name was EOSat, but later on, its name is changed to the Landsat. Okay. So, like Spot satellite, Landsat is also having a series of satellites. Okay, the first satellite of this Landsat series was launched in 1972. Then the second satellite, that is Landsat 2, was launched in 1975, and later on, three more satellites of the series, that is Landsat 3, Landsat 4, and Landsat 5, was launched respectively in 1978, 1982, and 1984. Then the sixth satellite of the Landsat series, that is Landsat 6, was launched in October 1993. Okay. And in 1999, the seventh satellite of the Landsat series, that is Landsat 7, was launched. And out of all the satellites which is launched with the starting of Landsat 1 satellite. Only Landsat 7 and Landsat 5 are still working, and recently Landsat 8 satellite was launched in 2013, and it is also providing the data sets in different multispectral bands, different multispectral images. Okay, so most of the remote sensing satellites are sun synchronous. So like spot satellite, Landsat satellites are also sun synchronous, and its inclination is about 8 degrees of a polar orbit, and its revisit time or repeat cycle is about 16 days, and that so that it can acquire the image of the same area around 10 a.m. every day. Okay, it takes around about 90 minutes. It takes about 99 minutes to complete orbit, and the distance between the ground tracks of the consecutive orbit is 2752 kilometer at equator. By following the earth rotation with each pass, it can keep crossing the equator at the same time. Okay, so this is the swath of Landsat series satellites. The swath width of Landsat series satellite is around 183 kilometer wide, and although that includes overlapping area, since data frame is around only 170 kilometer. So for every 16-day cycle, it captures the entire Earth in 233 orbits. Means it repeats 233 times to complete the entire Earth, and for each 16 days, it captures the same area on the surface, on the Earth surface, which is known as revisit time or uh, repeat cycle. So Landsat 4 and 5 satellites having two different types of sensors. It captures the images two different by using two different multispectral sensors, that is MSS and TM. TM means thematic mapper. And the first sensor was used in Landsat 1, that was MSS, that is multispectral scanner. It was started on Landsat 1 satellite, and its resolution was around 80 meters with four spectral bands, that is ranging from visible to near infrared bands, that is having blue, green, red, and near infrared bands. Four spectral bands was in multispectral sensor. Only Landsat 3 MSS sensor had a fifth band, that is thermal infrared. This is the comparison of two different sensors of Landsat series satellites, MSS and TM. MSS having four different spectral bands, green, red, and IR. That's wavelength is written here. And the thermal sensor is having total 7 bands, starting from blue, green, red, NIR, short wave infrared, thermal infrared, and short wave infrared second band. And the respective wavelength intervals of different bands are written, and it is having the spatial resolution of 30 meter in comparison to the spatial resolution of 82 meter of multispectral scanner. The thematic mapper sensor is having more bands, having better spatial and radiometric resolution, and both kind of improvements in the resolution in terms of spatial and radiometric resolution, plus the fact that the green and red bands are narrower makes it better for the vegetation discrimination. And also near infrared band used in the thermal infrareds, also the near infrared band used in the thermal mapper sensor is narrower and centered in a region that is highly sensitive to the plant vigor. These are some of the applications of different spectral bands used in the Landsat TM sensor. Blue band is very much useful for water body penetration, soil water discrimination. Green band is very much useful for identifying the reflectance peak of the vegetation, that is having used for the assessment of weather. Red band is very much useful for the chlorophyll concentration, for identifying the chlorophyll concentration and plant species. Near infrared band can be used for the discrimination of vegetation types, vigor, and biomass constant, delineating the water bodies. Mid infrared, thermal infrared sensors are also very much useful for the analysis of vegetation stress, soil moisture, and thermal mapping. So different spectral bands have different applications. Depending on our requirement, we can use any of the bands present in the Landsat TM sensor. These are some of the sample images acquired by the Landsat TM sensor. It's an sample image of Salt Lake City area acquired on August 14, 1990 and October 17, 1999. Differences in the color due to the growing season. So this is the comparative analysis of the images acquired by Landsat TM sensor on two different dates over the Salt Lake City area, and you can see the differences in the color due to the growing season. One image is from August month and second image is from the October month. So you can have the clear difference because of the growing season. So Landsat 7 uses new sensor, Landsat, that is ETM plus. Initially it was having TM, thematic mapper, but now after that Landsat 7 was launched with a new sensor that is called enhanced thematic mapper ETM plus. Okay, it stresses the continuity with the Landsat 4 and 5 that uses the similar orbit and the repeat pattern as well as the similar swath. The only difference between TM and ETM plus is that there is an additional band of panchromatic band in the enhanced thematic mapper plus. So these are the specifications of Landsat 7 ETM plus. You can see here an additional band of panchromatic band. An additional panchromatic band was included in Landsat TM ETM plus, Landsat ETM plus sensor, and rest of the bands are the same with Landsat 5 TM band, TM sensor, but the only addition is the panchromatic band in the Landsat T7 ETM plus. This is a sample imagery acquired by the Landsat ETM plus sensor over an area. Okay, this is another example of the image captured by the Landsat 7 ETM plus sensor. It is a composite of shortwave infrared, near infrared, and infrared bands. And this image shows the man-made features as well as the dense forested area and agricultural land. This is another example of the this is another example. This is an image which was captured by Landsat 7 ETM plus sensor, and you can have different earth surface features like you can identify wetlands, urban area, open water, and forest using this satellite image. Another important remote sensing satellite, the sensor that is known as IKONOS. It's a very high resolution satellite developed by the Space Imaging that was launched in 1999. It is also having sun-synchronous orbit, and it crosses every area on the Earth surface at 10:30 a.m. every day. And its revisit time and repeat cycle is around 11 days, and it is highly maneuverable, can point at a new target and stabilize itself in a second, and that enables it to follow the meandering features. The entire spacecraft moves, not just the sensor. So Icono sensors can collect the data at an angle of up to 45 degrees from the along track mode and across track axis. This allows for the side-by-side and fore and aft stereoscopic imaging, and its swath width is around 11 km at its nadir, and the image size is around 11 km by 11 km, but user specified strips and mosaics can be ordered as per the requirement, and it can also employ a linear array scanner. Iconos data or Iconos sensor collects the images in two different modes. First mode is panchromatic band. It collects the images in panchromatic band that's range is around 0.45 to 0.90 micrometer. It is having very good, very high spatial resolution of 1 meter. And second mode of the image acquisition by Icono sensor is multispectral bands. It is having three different multispectral bands. It is having blue, green, red, and near infrared multispectral bands with a spatial resolution of 4 meters. And in case of multispectral images acquired by the Iconos sensor, its radiometric resolution is around 11 bits, that is around 2048 values. So Iconos is also having two different sensors. It captures or it acquires the data over the Earth surface in panchromatic mode as well as in multispectral mode. In panchromatic mode, we can have the spatial resolution of 1 meter. That is very much important. That is very much useful for detailed urban mapping, for any kind of cadastral mapping. That is very much useful for land information system, for the development of land information system and management of land records. Another mode of image acquisition by the Iconos sensor is multispectral mode, that is having the spatial resolution of 4 meter. It includes 4 different bands: blue, green, red, and NIR, having different spectral ranges, and its radiometric resolution is around 11 bits. This is a sample image of an area near the Winter Olympic site acquired by the Iconos sensor. It is an image of having 1 meter spatial resolution, so you can see it is providing very high detailed information about the Earth surface. That is very much useful for land record management and development of land information system. Okay, so this is another image acquired by the Econo Sensor over Dubai area. You can see the high visibility of different Earth surface features. You can have the fine details about different Earth surface features. So these kind of high resolution images, these kind of images with very good spatial resolution can be used for managing the land record. For it can be used for cadastral mapping with good details. It can be used for the development of uh, efficient land information system that can be used by acquiring the information about different land parcels. By using these kind of high resolution images, it's very easy to identify a specific land parcel, and you can map easily each and every land parcel on the earth surface. That will be very much useful for the cadastral mapping, or you can say that is very much useful for the development of a land information system on of that area. Okay. This is another sample image of an area near to Rome acquired by the Iconos sensor with 1 meter spatial resolution. So the very fine details are available by having 1 meter spatial resolutions. You can map each and every building. You can map each and every roads and other features, other urban features. That is a prerequisite for the development of land information system and land record management, cadastral mapping, and etc. Okay, this is another 1 meter spatial resolution image near to Africa. Another high resolution image. The sensor which provides high resolution image is QuickBird. The QuickBird satellite sensor was successfully launched on October 18th, 2001 by the Vandenberg Air Force Base, California. You can see the details. You can see the high resolution of the QuickBird sensors, providing very good details about the urban area, very good details about different urban features. Okay, another high resolution image or high resolution sensor is Worldview 1. It is a part of what is to be a 3 satellite constellation, Worldview 1. The group includes QuickBird, Worldview 1, and Worldview 2. The ultimate goal of this constellation of high resolution satellite images is to have all 3 systems working together to provide global visual coverage commercially at the highest possible spatial resolution as quickly as possible. So Worldview 1 satellite was launched on October 18th, 2007, and it carries only panchromatic sensor that provides black and white imagery to the commercial use, and it can provide you the spatial resolution of 0.5 meter at nadir, and its swath is around 17.6 kilometer. So by utilizing the Worldview 1 image, we can have the spatial resolution of 50 centimeter. It is having only the panchromatic sensor with mounted on this satellite, and its swath width is around 17.6 kilometer. These are some of the characteristics of Worldview 1 satellite or sensor. It's a sun-synchronous satellite, as most of the remote sensing satellites are based on sun-synchronous orbit. Its altitude is around 496 kilometers. The period, or the time taken by the sensor to complete one orbit around the Earth is around 94.6 minutes. Its revisit time is around 5.4 days. That is having the spatial resolution of around 59 centimeter or less. The lifespan is around 7.25 years, and its resolution is around 50 centimeter at the nadir. So this is also a series of satellites: Worldview 1, Worldview 2, and Worldview 3. Okay, these are the series of satellites, and they are providing these satellites, or these satellite series are providing very high spatial resolution images. This is the image acquired by Worldview 1 sensor with spatial resolution of 0.5 meter, that you can say 50 centimeter spatial resolution images. It is very good detailed, very fine spatial resolution images, so you can get very fine details about the urban area. That can be very much useful for the cadastral mapping, for any kind of land record management, for digitalization of every land parcel, and these can be used for the development of land information system. So this is a sample image acquired by the Worldview 1 satellite. This is another image acquired by the Worldview satellite sensor, having very fine spatial details, that is around 0.5 meter spatial resolution images. So you can see how good details can be achieved, can be received by the Worldview 1 satellite sensor images. This is all about different satellite sensors available for the cadastral mapping, for the urban area mapping, or you can say the images acquired by high resolution sensors. The images provided by high resolution earth observation satellites can be very much useful for land record management, for digitalization of different land records, land parcels, cadastral mapping, and that can also be used for the development of special economic zones, different industrial and commercial activities on the earth surface, and these are the part of the land information system. So earth observation satellites, earth observation series of satellites can provide you very good details, images of an area that would be very much useful for the land information system. So thank you very much for today's class. Today we have discussed about the uh, role of earth observation satellites. We have discussed different satellite sensors starting from Spot, Landsat, QuickBird, Iconos, Worldview, and we have discussed different characteristics and properties of these sensors and how they can be used for the development of land information system, for the detailed cadastral mapping, for land record management, for digitalization of different land parcels, and other applications. So thank you very much for today's lecture, and then in the next lecture we will discuss more about the earth imaging satellites. We will discuss more about the earth observation satellites and earth observation data sets for the land information system. Thank you very much.